It is possible to combine multiple comparison or Boolean values together using some operators such as or and as in the logic that you would know from your classes. So you can also negate the result of a Boolean expression or a Boolean value using the not keyword. So there's a precedence among these three operators. So when you call the not operator before a Boolean value or an expression, it's going to have higher precedence than and the and keyword or and operator is going to have higher precedence than the or operator. So we can combine these multiple Boolean expressions or variables containing Boolean values, true or false, using these three operators. You can also use parentheses to specify a specific precedence among and or not operators. So there's one note that the ampersand and the pipe sign are not used for and or operators in Python as they would in C or Java. Using double ampersand is and, or double pipes is or, but using them as a single operator is bitwise and or. We will not discuss them in this class, but they have specific meanings. So you have to use the and as well as the or words as they are when you want to combine multiple Boolean expressions together. We have an example in this table that specifies when some citizen wants to, or some traveler wants to make a journey in less than 10 kilometers, less than or equal to 10 kilometers. So a regular civilian would be charged as O.5 times the distance traveled. A student is going to be charged as O.3. A teacher would be charged as O.4. And seniors might be charged as O.3, similar to students. So they have the same value. If somebody is traveling an additional amount of distance over 10 kilometers, that additional distance should be charged as O.3 for regular civilian fare. Students will be charged as O.1 for the additional or extra amount of travel. Teachers and seniors have the same amount. They have the common calculation. So we can write a function that makes a call to this calculate fare function we have defined. The calculate fare receives the distance to be traveled or has already been traveled, whether the person is a student or a teacher or a senior. The person might be a student, teacher, and senior at the same time. This is possible. But there is an ordering of evaluation between these conditions. So we first check whether the distance is less than 10 kilometers or equal to 10 kilometers. And if this is true, if the first part of this conditional expression is evaluated to true, it's going to continue checking whether the student or senior parameters are set to true. Okay, so if this one is set to true, it's not going to check this part because true or anything is going to be evaluated to true. So there's no need for checking this part. This is called a shortcut evaluation, short circuit evaluation. But if the person is not student and if the person is a senior citizen, this is also going to evaluate to true because false or true is going to be true according to the Boolean logic. So the function is going to return distance time O.3 according to our table. So if the distance is less than 10 kilometers, less than or equal to 10 kilometers, and the person is either a student or a senior citizen, the result is going to be multiplying the distance by O.3. If that is not the case, if the distance is less than or equal to 10 kilometers and the person is a teacher or the teacher variable is set to true, this is how we can read this function. And then it's going to multiply the distance with O.4 and return that amount to be charged from the person's account. If that is not the case, so the distance might be less than or equal to 10 kilometers, but the person is not a student, not a senior citizen, and not a teacher, so it must be a regular civilian. It's going to multiply the distance by O.5 and then return that as the calculated fare to be charged. If this is not the case either, so the distance might be more than 10 kilometers, it's going to first calculate the charged amount of the first 10 kilometers. So this is going to make a call to the function itself. Okay. If a function makes a call to itself, this is called recursion, which we will discuss in the next chapter. It makes a recursive call to itself, calculate fare, with the distance being 10 kilometers. So the actual distance, the initial distance might be 15 kilometers, but the first 10 kilometers will be charged according to this part of the table, and the remaining 5 kilometers is going to be charged according to this part. So we first calculate the fare of the first 10 kilometers using this function, 10 kilometers. So the person might be a student, teacher, senior. So whatever values are assigned to these parameters are going to pass to the function call once again. And it's going to check the first part. So the distance is less than or equal to 10 kilometers in the second call, this part. So these three conditions are going to be checked. If this is not true, this is not true, this is not true, this might be true. So if any of these are true, they are going to return the value. So these parts are not going to be executed. So make a call to the function with 10 kilometers. It's going to decide some value O.3, O.4 or O.5 depending on the first 10 kilometers, and then it's going to receive that value obtained from this function call, and it's going to add the remaining part. So distance minus 10, so we had 15 kilometers that have been traveled. 15, it's not easy to type on the screen, sorry, to write by hand. 15 kilometers 15 minus 10 is 5. So distance minus 10 is 5. So if the person is a student and we have calculated some amount, which is O dot 3 times 10, which is 3. We have 3 received from this calculation. And we're going to add 5 times O dot 1, which is O dot 5. So the student is going to be charged as 3.5 for 15 kilometers. Based on that calculation, if the distance is higher than or greater than 10 kilometers, and if the person was not a student, because if the person was a student, this return would cancel out this part of the code and complete the execution of calculate fare. And if the person is not a student, then the person might be a teacher or a senior. If so, it's going to first calculate the amount to be charged for the first 10 kilometers. And then it's going to calculate the remaining part of the journey according to O.2, which is the value for the excessive amount, the additional amount of travel here for teacher and senior citizens. So we have combined two Boolean values using the OR keyword. So if either one of these are true, this part of the parentheses is going to return a true. If the teacher parameter was true, it's not going to evaluate this part because only one of them is sufficient for obtaining the result of this parentheses, this combined Boolean expression. So if the teacher parameter was set to false, then it's going to check whether the senior parameter was set to true. If so, it's going to conclude that this part is true. So if the distance was initially greater than 10 and there was a true result obtained from this part, it's going to execute this single line of statement, which tells us to first go and calculate the fare from the first 10 kilometers based on the values of these variables, arguments or attributes, parameters. And then whatever we obtain from there, we could obtain if teacher or senior. So let's say if that was a teacher and not a senior person, so it's going to calculate O.4, which is 4 for the first 10 kilometers, and then it's going to calculate O.2 multiplied by 5, which is 1. Okay, 5 times O.2 is 1. So the teacher is going to be charged 5 Turkish liras for the first 15 kilometers. So the 4 is coming from the first 10 kilometers and the 1 is coming from the remaining 5 kilometers according to this table. So if this was not the case, if the person was not a student, not a senior, so the person must be a regular citizen. So this is false, this is false, this is also false. It's going to make a call, a recursive call to this function. And when we arrive here with the distance value of 10, we see that distance is less than or equal to 10, but not a student or a senior, so we don't execute this part. No return. Not a teacher either, we don't execute this part either. So we come to this part that distance is less than or equal to 10. We multiply 10 by O.5, where we obtain the value of 5 Turkish liras from the first 10 kilometers. So the person was not student, teacher, or senior. And then for the remaining part, which is 5 kilometers, we multiply the regular citizen by O.3, which is 1.5 for the 5 kilometers. And the person is going to be charged as 6.5 for 15 kilometers. That's the regular citizen fare of this travel company. So let's make these numbers 15 instead of 20, so we can check our results. We can see if my maths is still holding. So when we run this, we obtain these results. So the first part is checking a regular citizen. So student is set to false, teacher is set to false, and senior is set to false. So the regular citizen for the first 10 kilometers is charged as 5 Turkish liras. And as senior citizen, not student, not teacher, but a senior citizen is going to be charged as 3. And in this case, we have the second line charged, second line to be charged as a 3. So when we are calculating it for a teacher, we are going to see that the result is 4. So the teacher parameter is true only, not a student, not a senior citizen. So the teacher is going to be charged as 4 units of money. And if the person is both a teacher and a senior citizen at the same time, so that the person is going to be using the person is going to be receiving the discount according to the first check here. So the seniority of the person is checked before whether the person was a teacher. So the person was a teacher and a senior at the same time. So if we write this if above the first if, the person would be charged as 4 instead of being charged as 3. So the order of if statements is very important. If the person is a senior person, senior citizen, their travel charge is going to be 3 for the first 10 kilometers. But if the person is a teacher but not a senior, because if she was a senior citizen, they would be calculated with this result. This is not the case. The person was not a senior citizen, so it's going to be calculating this part. So if the person is both a senior and a teacher at the same time, this part is going to conclude that the charge is going to be 3 for the 10 kilometer part. And it's not important whether the person is a teacher or not after this calculation, because the function simply returns the calculated value and terminates this part, just cancels out the remaining calculations for the first 10 kilometer. And if we continue with the next part, which says if the person is a student but not a teacher and not senior citizen, so the students are charged for 3 liras for the first 10 kilometers. And if the person is both a student and a senior citizen, the result is again going to be 3. Okay, so this is the student only version, this is the student and senior version, because the code here concludes that whether a person is a student or a senior, they're going to be charged as 3 liras. So that is the exact case. The person was a student and a senior, so we multiply it with O.3 for any of them. Just calculating for student is sufficient. So this is the first one. The condition was student or senior. So we don't need to check this part because this already evaluates to true, which we have specified as the Boolean value itself. So the next check is whether the person is a student and a teacher at the same time, which might be possible. So when we go into the code, we see that the person is charged as 3.0 instead of 4, as in the teacher case. This is also due to the ordering of our conditional checks. Here we have the student check before the teacher check. So we see that the person is student and teacher at the same time, but not a senior person. This part of the expression returns true. So student is true, senior is false, but the OR operator returns true or false, concludes that the result is true. So this part is evaluated to true, and distance being less than or equal to 10 is true because distance was 10 or 7, whatever. So true and true coming from this part is true. The actual expression was like this: true and parentheses true or false. So this is evaluated first, the parentheses. True or false is true. True and true is true, as you would all know from the logic lessons. So if you continue with all these statements, you're going to see that they're evaluated to 3 because student part holds, which makes the calculation to be 3 liras. In the next part, we see that we have more than 10 kilometers being traveled. So when we check these conditions for regular citizens, so not a student, not a teacher, not a senior. So this is for people without any of these properties. So they're going to be charged for 5 liras for the first 10 kilometers and O.3 times the additional distance, which is 5 kilometers. So they have 6.5 calculated here for their 15-kilometer journey. And you can also practice the remaining part accordingly. The one important thing that you should know is the order defines the calculation amount. So if we move this part above the first part, the calculation is going to change. If a person is a senior teacher, so if a person has the age above 65 or so, and is a teacher at the same time, the first check is the first conditional check is controlling whether the person is a teacher or not. So the person is a teacher and the person is going to be charged 4 Turkish liras regardless of whether the person is a senior or not. So actually the person would get more discount if seniority was checked before the teacher condition check. So when you design your code, you should be careful about which rules or which conditions are going to be evaluated before the others. If you want to charge less, you should move this part above the seniority check. So if a person can get more discount in some condition, in this case, this might not be the case for some other program, some other case. So this is social state rules that benefits their citizens above anything. So the most amount of discount can be provided to their citizens. So O.3 is checked first, O.4 is checked second, and O.5 is checked last. So if the person is any one of these, they're going to be charged accordingly. If not, they're going to be charged as regular citizens. So this depends on your calculation. So in this case, we have O.1 first, O.2 second, and O.3 last. If you change the order, you're going to give them, you're going to either charge them more if they have some specific conditions that makes them eligible for being charged more. You might prioritize that first. So if this might be a fair calculation, but you might be giving some kind of refund to those people. So you might want to change the ordering of these calculations. So if you're dealing about providing refunds, you should first check the higher refund amount before the lower refund amount. So if this is for taking money from people, so we want to take less money from the people, so we care about our people. But if you want to implement this code according to calculate refund, so you first charge some money and then you want to refund some of it, as in this case of the metrobus in Istanbul. So you first make your card read by the system. They take some money, and then when you leave the bus system at any stop, you just make your card read by the system and they give you some refund. So you may want to benefit your citizens more, so you should move this up. So if this case holds, you should refund them more. If not, you should refund them less, and if that is not the case either, you should refund them even less. So this depends on the logic of your application. If you're taking the money and if you want to take less money, you might want to charge more money. That depends on the case. But if your intention is to charge less money, you should check the least amount of coefficients first, so that if they fall into this category, you're going to charge them less. If not, you're going to charge them more and even more. If this is the case of refunding, you should first check this condition so that you can refund them, you can give their money back more. And if that's not the case, you should check this one for the second. In order to do that, you should move these conditions above the others, like here, etc. So you get my point. So we have a truth table where we have variables such as a, b. So if a has the value of false, b has the value of false, using the AND operator between a and b concludes the result to be false. And similarly, the OR operator is going to evaluate to false, because false or false is equal to false. When you write the expression like this, not A or B, not A has higher precedence. So it's going to convert the value of A to true because it was initially false here. It's converted to true, and true or false is simply true. But when you want to negate the OR operation altogether, you need to use the parentheses. So this is false. Negating false is true. And in the second line, we have false and true for A and B respectively. A and B becomes false because true and false is false. A or B is true because either of them is true. Not A or B is true. So this first negates A to true. And true or true is again true. Or true or anything is true. Okay. And not A or B is A was false or true. The result of this expression is true. Not true is false. So the result is false. And it goes on and on. So in logic, you would expect all these to be performed. All these steps to be performed. Okay, it just calculates them inside out and concludes that true. But in programming languages, we have this short circuit evaluation rule. So for the OR operator, if the first operand on the left is evaluated to true, the remaining part is just ignored because the result is not going to change. So this part is not actually executed because A or B or this part. So if A is true, the remaining part is unimportant. So we have the true for the OR operator, and the remaining part is also OR. So it calculates A is true, whatever the remaining part is, it's not important for us. We're not going to waste time on calculating those values. But in case of AND operator, it has to check whether all of them evaluate to true. So it doesn't work for true and B and this part. It has to get true from each one of them if we are using the AND operator, A and B and the parentheses part. Okay, so if this is true, it's going to check whether B is true as well and whether this part is true as well. But if A was false in the beginning, it's going to ignore this part because there is no way that this expression is going to produce a result that is equal to true. Okay, because A makes A and B and something else. When A is equal to false, this is going to conclude that everything in this expression is going to result in false because of A being false. False and any other thing is equal to false. So there is no meaning in evaluating this part because there is no way of obtaining a true result from this expression because of A being false. So we can use this example here by altering the values or changing the operators. So our getValue function returns false. In this case, it returns false. So when we call it first time, it's going to return false. So we're going to make a call to that function. It's going to return false, but the operator is OR. So it keeps on trying until it finds a true value returned from this expression itself. Here, let me conclude that this is false. But there's something else to try. We have the OR operator. False or true. Oh, okay. I have now found a true for my expression. There's further getValue call in my expression. But this is not necessary because I have already found that I have a true for this statement. So this is a compound Boolean expression using two OR operators at the same time. Whenever a true is obtained for the OR operators, the result is concluded. There's no need for calling this getValue for the second time. As in this case, we have only made one call. We have only one output, as in this case. Okay, and the result is true. This was false. This is true, and this concludes the entire evaluation because this is also an OR operator. True or anything is true. There's no need to make a call to this getValue function once again. So let's change our result to be true. So this function, whatever this function is doing, it's generating a true result. Okay. And when we make a call, it's going to make this first call again because there is no way of escaping from this function call. This might be on purpose, okay, intentional, because you want some initialization of databases or making some calls to somewhere that you want to inform that part of the application that you're running this code, whatever. So you make a call to this part, it returns true, and there is no need to call the remaining part because they are all OR operators. So the first OR operator actually defines the methodology whether you're going to execute the rest of this code. So getValue returned true. There's no need to call this part. And we're going to conclude that our result is true. Let us first assign this expression to a variable. So this is similar to printing And now we can change our operators one by one to AND operators instead of OR. So if we change the first OR operator to AND, it's going to check this first part due to the precedence of the Boolean expressions. As you would remember, the parentheses has the most precedence and not has higher precedence, and the AND operator and the OR operator. So the order of precedence is parentheses, not, and, or. So in this case, we have an expression that uses the AND operator as well as the OR operator. So this operator has higher precedence as there are no parentheses specified. So it's going to first obtain the result from these two, and then it's going to evaluate this part. However, if this get value produces a true result, this first part is going to evaluate to true as well, and there's going to be no need for executing the get value function for the second time, or any other function you might include here. In this example, I'm using the same function so that I can alter or modify the returned result to show you how it's going to behave. So the get value function currently returns true result. If we run this code, it's going to call our function, which is going to return true for us, and true is going to be ANDed with true. It's going to return the result as true, so there's no need to call this get value for the second time. But if you modify the return value, or if our function returns some false value depending on other calculations, it's going to call the get value function for the second time in the hope that it's going to obtain a true result, which might be possible, again depending on other factors. So it first makes a call to the get value, and it returns this text. It prints this, outputs this text using the print function, and returns the value false, and false and true is going to be false. So there's no conclusion here to the value true. It's going to continue with this OR operator if it can find a true result, making a call to the get value function. Again, we haven't modified the input, so the output, the result, return result, so it's again going to return false. So false or false is going to be false, and the result of the Boolean expression is false. This is the assigned value. So if we change the second operator instead of the first one, let me make a copy of this line and comment out this part so we don't lose our code. So instead of the first one, I want to change the second operator. This is just a demonstration how they would behave on different variation of operators. Run this once again. So it makes a call to the get value, which is returning false. Okay, it's always returning false at the moment. So there's no conclusion here. It keeps on trying the second part. So the expression is evaluated from left to right, by the way. So if it received a true value from the getValue function, it wouldn't bother executing the next part. So it tried this first time, it received the value false, and kept on trying with the second part, true and, okay, it's going to continue evaluating this and part. So true, okay, I can continue with the and, because true and something defines the result. So this thing is false. I already got false from here. True and false is already false. And the result is false. If we modify the output of our function to true and rerun this code, it first makes a call to getValue, which returns true, and the operator is OR, so there's no need to make a call to the remaining part. So true or something is already true. So the getValue function is not called for the second time. Let me go back to the content now. And you can try it with different functions, different return values, or different variables that receive Boolean values from comparisons or calculations, and experiment on the results, so that you get familiar with the order of operators or the precedence of operators and the output they produce. It's important that you get used to the OR and NOT operators. So you might use different versions of those combined Boolean expressions. One important thing, that when you want to negate a Boolean expression, there's a law called De Morgan's law, or De Morgan's law. So it states that when you use the not operator on a group of compound Boolean expressions, the result is both negating the operands and the operator itself. So OR becomes AND. So not A, not B. So not A and not B. You would know this from your classes. The operator is switched. OR becomes AND, or AND becomes OR. Also, the values of each variable is also negated according to this law. This might be handy when you want to convert some code like this. Let me type it in for you, this example. So I have some condition, if not A or B, okay. I have this condition logically. Let's say I have my A value received from some function as true, B value received as false, and the logical expression is that execute this part of the code only if A or B is not equal to true. So if A or B is true, that's the logical output, but I want my code to be executing this inner statement, okay, if this is not the case. So this is one way of writing it, and the other way is if Oops, sorry, not the exclamation mark, but the not keyword. The other way of writing the same thing is not A and not B. Okay, so this is the way you are going to convert it if you need to clarify your code, if you want to make a change. So things may change over time in your code. So this is one way of converting the Boolean expressions from one to the others. So I think this is all about this part of the discussion.